Hey everybody, alright, so sorry it's taking me so long to get a video up, but I'm going to beast these out today, even though it's a gorgeous Friday afternoon, but I've got my window open next to me, so if you hear car alarms or a train, we'll all yell at it together. You'll be sitting at your computer being like, "Go away, train!" And I'll be like, "Yes." I don't even know what you're talking about, but excuse me if my voice seems a little harsh. I've developed a little bit of a cold or allergies or something, not sure. But anyways, yeah. So let's jump right into it. This is going to be a quick video. From the title, you probably already know what it's about, so I'm going to tell you anyways. This is going to be about naming. We're going to go over naming of, I, I, I guess we'll go over naming like standard ionic compounds and covalent compounds. And then we'll also touch on some organic compounds. Like we'll just kind of, this will be an all-around naming. So it'll be a quick video. I'm gonna try and keep it under 10 minutes if I can, or even less than that. But let's just jump right into it. So I think I'll just do maybe one or two examples of each thing. Ultimately, I know I hate doing this to you guys, but ultimately, it just kind of comes down to knowing or memorizing the naming conventions. The IUPAC has a certain way of doing things, and sometimes it's non-intuitive and sometimes it's very intuitive, so you just kind of have to get to know what their rules are. So let's jump right into it. Let's start out with a very, very, very simple case. Let's do it, and I'll just do this up here. So NaCl. Okay, we all should know hopefully what that is. That is table salt, right? Or a substituent of table salt. So how would we go about naming this? Well, first we recognize that it's a metal bonded to a nonmetal. So that's the first key. You want to know that this here is your metal, and this, the chloride ion, is your nonmetal, right? So right off the bat we're thinking, okay, I'm going to scroll that down in case you can't see that. So right off the bat we're thinking, all right, we're dealing with that style of naming. So what you do first is you write the full name of your metal. So this is going to be sodium. And then we write the first, I guess the way I would describe the first syllable of the nonmetal, and then tack on an ide, an IDE to it. So it would be chlor, which is like that first syllable, and then ide, so chloride. So the answer to this one is sodium chloride. Well, we probably already knew that, and you're probably sitting in your seat like, okay, Drew, that wasn't helpful. And you're right, it probably wasn't, because that was a simple case. So I'm going to throw one that's a little bit more difficult at you. So let's do... yeah, here we go. Mg3PO4. Okay, so what's going on here? We've got a subscript 3, and we've got this PO4. What the heck are we doing? I mean, let's slow your roll, Drew. Slow your roll. Well, okay. Here's what it is. Again, we come back. We're like, well, we've got a metal bonded to this complex right here, this PO4 entity, if you will. But it's still, this stuff here is still non-metal, right? Phosphorus, oxygen, that stuff's still part of the nonmetals. It's just one of the polyatomic ions that is on a list of things that you guys need to know. So yeah, for your exam, here's a pro tip for the exam. Wow, that's not how you spell exam. That's okay. I'm not gonna fix it. Know your polys. There we go. Okay, know your polys. Okay, you gotta know those guys. So you're gonna want to know what that guy's called. I already know what it's called, so I'm gonna give you that answer here in a second. But you're gonna want to know them through and through, know them by heart. You can do it. I know you can. I had to do it when I was in your position. I know you guys can do it. So, what we have here is magnesium. So we've got a metal bonded to a nonmetal. So first things first, write the name of the metal. Magnesium. Magnesium. Now, here's the tricky part. Do we say tri-magnesium because of this 3? Well, no, we don't say that. In fact, the only reason why the only way this 3 contributes to our name is that we know from the polyatomic ions here that PO4 actually has a -3 charge, right? So that means you need 3 magnesiums to offset that -3 charge on the this group here, which I'm going to tell you the answer here in a second. I almost blurted it out. I actually had a brain fart and couldn't remember it, but I almost blurted it out once I did get it, and that would have not made sense. So we need 3 of these magnesiums to offset this PO4 because it's got a -3 charge. So what that tells us is that this is magnesium 1, and you got to indicate the charge. You have to indicate the charge. Maybe a bad example. You may not ever encounter magnesium 1. I'm just going over naming, so if there's any chemistry sticklers out there, it's like, well, that's not real. I don't really care. I'm just going over naming, just so we can name these made-up fictitious molecules. All the rules still apply, whether or not these are real compounds or not. So let's keep going. This is actually called a phosphate group, so it's going to be magnesium 1 phosphate. Phosphate. There he is. That's not right. Who cares? I think there's an F there. Phosphate. Okay, I'm seriously like sick, so I'm probably making noob mistakes. I'm not even gonna worry about it. I don't even care. But that's okay. Yeah, it'll be fine. It doesn't matter. That's an F or pH. I'm drawing a blank. So anyways, that's how you name these guys. You don't have to deal with tris or dis or anything when you're dealing with metal bonded to a nonmetal. And these are considered ionic compounds. And a good way for me to understand the difference between ionic and covalent is an ionic compound is kind of like a magnet in a sense. You have 2 magnets stuck together. You've got the positive end of the magnet, and it wants to interact with the negative end of the magnet, right? So that's kind of how you can think of these ionic relationships, right? But with covalent, it's a little different. And so let's jump into naming nonmetal bonded to nonmetal. So let's go ahead and do that. Yeah, so we would jump right in here. And yeah, here's a good one. This guy. Probably never thought about what that guy's called. Yeah, didn't think so. So what will we call this? Well, you're like, oh, well, duh, that's just water, right? Well, actually, it's not. Well, it is. It is water. But to go by the IUPAC convention, there's actually a different way you do it. Now, since this is a nonmetal bonded to a nonmetal, then we have to take into consideration adding the prefixes like di, tri, tetra, those types of things. So what we would actually end up doing is we would say this is dihydrogen oxide. Again, we have oxide. You write the first thing fine. You add the di because there's 2 of them, and then it's oxide. So it's dihydrogen oxide. So it wouldn't be oxygen dihydride. That doesn't make sense. It's always dihydrogen oxide. You write what comes first and then what comes second, right? That's the naming convention. So that's kind of a neat thing. You probably never thought, oh, what's the actual name of H2O? It's dihydrogen oxide. Let's do another one. What if we have, let's see if I can find a good example, if I can come up with one. Oh, I can't find one. So let's just come up with this. So let's use silicon. Silicon. Oh, this will be good. I'll do it the opposite way. Silicon. What should we do? Yes. Silicon tetrafluoride. Again, I'm not a stickler on spelling, so please don't be a stickler with me on spelling. If I mess any of these things up, is that how you spell fluoride? I don't even know. I don't even care, because I'm not feeling good. Anyways, I just like making these videos, and that's what I'm going to do. Even though I'm sick, I still will put a video out for you guys. So what would this one be? Let's go backwards on the exam. What if you get silicon tetrafluoride? And what is this? Well, shoot, I don't know. It's actually quite simple. You right here, you know what that is. You look on the periodic table and be like, okay, that's Si. And you know what fluoride is. You can look right on the periodic table. You know what fluorine is. And you know you just drop the ene and add an IDE. So it's like, okay, well, this is fluorine, or fluoride, but it's just an F, right? And then this, what does tetra mean? That's one thing you should also know. Di, tri is 3, di is 2, tetra is 4, right? So this is going to be SiF4. So that would be the case. I think silicon can actually go up to 6. It can actually expand its octet, so you could have silicon hexafluoride, which would be this, right? So it can expand its octet. Neat little trick that silicon can do. So yeah. So that's naming for these guys. Oh, let's see. You may not be able to see that. Scroll up. If you missed all this, you probably saw hydrogen or dihydrogen oxide. But anyways, it's silicon tetrafluoride is this guy. Sorry, didn't realize I wasn't scrolling the page. Anyways, so and then you can also have this, which is silicon hexafluoride, right? So let's do one more set of naming. Let's name some organic compounds. How about that? That'll be good. So I think I'll do one example of when it's okay. Yeah. So we'll do this. Let's do this. I'm gonna draw the skeleton structure, and I hope you guys understand what the skeleton structure is. It's just easier to draw. So let's do this, and then this. There. Let's do that right there down the center. So first things first, we need to find our longest chain. I think she'll probably just give you one like this. I don't think she's going to include functional groups, or she or he, for the exam. But whoever may be watching this, it might be a he for you, it might be a she for someone else. But anyways, for your exam, or any exam in Gen Chem, I am running out of time. I need to wrap this video up. But you're probably going to get something like this in your level at the moment. So let's go ahead and count this up. So we've got 1, 2, 3. You want to find your longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 across here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 all the way around, so it doesn't really matter, but you have to pick the longest chain with the most amount, or the highest number of different things coming off of it. So if you look, this guy, 1, 2, 3, 4, 5, 6, 7, 8, 9, this chain here has a guy right here and a guy right here. A substituent here and a substituent here. I should be more scientific with my terminology. So this is the chain we're going to go with because it has the most number of substituents on that chain. So if we look, this is a butyl, 1, 2, 3, 4. That's a butyl group. This right here is a methyl group, and we want to arrange these things in alphabetical order. And but you also want to do your numbering such that it hits the I'm sorry, I'm drawing a blank, but it hits the substituent, the earliest substituent that it can. So we would actually want to do our numbering here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to name this butyl first because B comes before M in the alphabet, but we wanted to do our labeling to where it lowers these numbers as much as it can. So we have a 2 and a 5 as opposed to a 1, 2, 3, 4, 5, and an 8, basically, is what we would end up having. So that's why we number it this way and not starting over here. Does that make sense? So instead of doing 1, 2, 3, 4, oops, that'd be 4, 5, 6, 7. So instead of this, okay, so it's kind of a toss-up, but this is a 4 and a 7. a 2 and a 5 is more correct, because you're hitting this guy right here at this 2. It's just naming convention. I know it's goofy and weird. Did I miscount that? 1, 2, 3, 4, 5, 6, 7, 8. Oh, we wouldn't even do it. That's not even 9. I must have miscounted earlier. Well, forget I even said that. Don't even worry about those. For those of you who like know me in real life, you know that I'm uber goofball, and when I'm sick like this, I tend to make silly math mistakes. So let's just go. Let's just push through this. Let's go ahead and name this. So this is going to be a 5-butyl. That's not right. Y there, L there. 5-butyl 2-methyl. I always get my Y's and L's messed up. Let's start over. 5-butyl 2-methyl. 5-butyl 2-methyl nonane. Should be all this should be oops, right there, yeah. All this should be lowercase, by the way. I just don't pay attention to that, but it should be lowercase properly. And that would be what this guy's called. Right? So that's how you name these guys. I could do another example, but this is really what it is. You just figure out your naming, get your names in the lowest reduced numbers that you can. You want to hit this guy first because it's the second one. And then you just go on and name it. You had a 5-butyl 2-methyl nonane. And then to go backwards, if we were given, to make our lives a little easier, I suppose, if we were given 3-butyl 3-butyl 4-methyl nonane. We would work backwards from this, and we would first draw the nonane. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6. Start our numbering anywhere. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we just go, okay, at the 3 position, we have a butyl group. 1, 2, 3, 4. 1, 2, 3, 4. And then at the 4, we have a methyl going right up out of there. So, but actually, as I look at this, this really wouldn't make sense, because this molecule would actually not be, this wouldn't be how you would name it. But I just wanted to illustrate how you would go backwards. This molecule doesn't make sense. Hopefully it's clear to you why it doesn't make sense, because if we were to recount, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, this would actually be the longest chain, and then our name of this compound would actually be different. But oh gosh, you probably didn't even see that. Okay, well, I need to remember to scroll this page. Anyways, what I said, this really wouldn't happen. So if I get an organic chemist who watch this, they're gonna be like, that's not right, and I'll be like, okay, well, it's not right, you're right. If you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you actually get 11 carbon, like an 11 carbon chain here, which is undecane, I believe. So then this isn't actually the name of this compound. But I wanted to illustrate, if you were given this, could you work backwards? First thing you do is write the longest chain, and then just put those guys on there somewhere. So I hope that makes sense to you guys. Anyways, good luck on your exam coming up. I'm going to post some more videos. And again, please leave a comment, please subscribe, and hit that like rating if this helped. And yeah, leave comments about what you want to see me do in the future. And they don't even have to be science videos. You know, this channel could be for a lot of other stuff. You could, if you guys want to, you know, say, hey, can you do a funny science video, or can you do something, you know, I don't know. I will do whatever I can if you try and request it. In fact, I had somebody mention I should do a drunk science video, like drunk science, like where I'm like trying to work through a problem, but I'm just completely drunk off my tits. That would be funny, but I don't know if I'll do that or not, but that'd be cool. But yeah, I want to interact with you guys. So through the YouTubes and through the interwebs, please find ways to interact with me. So anyways, sorry this video was way longer than I wanted. Thank you for sticking around. Leave a comment, leave a like rating, subscribe, and I will see you guys later. See ya.